So I'm going to talk to you about the current state of SZ4D. As Donna said, I'm here representing as chair of the steering committee and chair of the executive committee. And I'll try to explain to you where we are now. So let's start at the beginning. The beginning is SZ4D stands for subduction zone in 4 dimensions, and the 4th dimension is time. And SZ4D began, really sort of started to take shape at a Boise meeting in 2016, which led to this SZ4D initiative report in 2017, which articulated the need for a major effort to understand the science underlying geohazards, including earthquakes, volcanoes, and landslides. This sort of was the nucleus of an idea that then became a priority in the National Academy's Earth and Time Decadal Report, which is the guiding document for EAR, the Solid Earth section of NSF. Because it was a priority, NSF decided to fund a research coordination network. That's a technical term at NSF, an RCN, which is an entity to enable collaboration and planning, specifically on subduction zones geohazards. Simultaneously, NSF also funded some other RCNs, including the Modeling Collaboratory for Subduction, which was a closely related enterprise, which has since merged with SZ4D. So who was involved in this RCN? A lot of people. The RCN was structured to have a number of committees, and I will explain these abbreviations soon, I promise. Overall, these committees involved 74 US-based scientists on one RCN committee or another, from at least 55 universities or research institutes. And those 74 people were representatives. They really weren't the only people involved in the RCN. They very much viewed themselves as representatives of the community. And over the course of the RCN, they reached out through webinars, Zoom meetings, satellite meetings, and in-person meetings, surveys. And overall, we count over SZ4D activities that we have engaged about 3,400 participants in SZ4D at one time or another. The SZ4D RCN, the sort of major working entities of it were these working groups, which were aligned with specific geohazards, since it is a geohazards focus. There was a faulting and earthquake group, which is known familiarly to its friends as FEC, and although I will try to keep the acronyms at a minimum, I'm going to slip. So FEC is faulting and earthquakes, and that group also includes tsunamis. The Magmatic Drivers of Eruption Working Group, MDE, and the Landscape and Seascapes Working Group, which includes the landslides, LNS. In addition to the working groups, the RCN included cross-cutting groups, integrative groups that addressed issues that were of interest to everybody. For instance, the Building Inequity and Capacity in Geosciences, BECG, I like to say they deal with the humans, and we're all interested in humans. So is a cross-cutting group, as well as the Modeling Collaboratory, which, as I said, started life as a separate RCN and eventually merged with components affecting all parts of the enterprise. And so SZ4D RCN had its kickoff meeting in January 2020 which of course was an awkward time to have just had a kickoff meeting. And that was our last in-person activity until mid-2022. And so to a large extent, SZ4D, our work has been happening in the virtual era, which is part of the reason we need this community meeting to get back together in person. It's been very, very, very busy in the virtual era. Most of the committees met every other week for 2 years straight. There were also other committees that sort of evolved organically to address particular needs. There's a lab group that kind of self-organized, a geology group that kind of self-organized. There were 4 virtual multi-day all-hands meetings, and the RCN, as I said, had a kickoff meeting in person January 2020 and next met in person in September 2022. There were 13 international webinars, which I think were great successes in bringing in the international community. That was one of the advantages of the Zoom era. And public forums, town hall, and all together, as I mentioned, we engaged 3,400 participants. All of this work, you know, where's this going? Why are all these committees busy meeting? Do they just like to meet on Zoom? This work led up to, in October 2021, a draft of an implementation report. That really was our charge from NSF, is that the RCN should produce a report that is a plan on how we get from this vision of doing something significant on geohazards to what it is we want to do. And to provide this draft report was released a year before the RCN was to wrap up, and with the idea that we would spend that year soliciting feedback. We'd get out our thoughts in October of 2021 and then do even more webinars and town halls and surveys and try to draw in even more of the community with this sort of concrete starting point for our discussions with agencies and potential partners. So since the draft report was released, the in-person world has resumed. In addition to being able to do some in-person town halls at AGU and online, we were able to bring in input to the draft report from potential international partners. Most notably, our first big in-person activity was a meeting in Chile in May 2022. You can see the picture there on the right. We had 70 people in Chile. That was the biggest meeting I had been to until this room. And a workshop in Potsdam, working with people who had been active in Chile for a long time at GFZ. We also did a in-person meeting, that one with all the acronyms there, CIG, CSDMS, MCS. If you can understand all those acronyms, well done. That was a modeling workshop to get together the various entities involved in trying to pull together the modeling community and joint resources for the modeling community to articulate their relative roles. We also managed in the spring to launch an e-newsletter as a vehicle to engage more of the communities. And I should have added up here, since the draft report released, SZ4Grads got launched as well, which was a is a graduate student arm of the operation. And then finally, as last week, as you all saw in your inboxes, I hope, the implementation report was released in its final form. This was a massive effort and something of a massive effort to read. Sorry about that. I hope you all have at least had a chance to read the executive summary, which is less than 7 pages. That should be digestible, and the font is really big. Please do read it. And I'm going to try to walk you through some of the key points right now, because this is our blueprint. This is our guiding document here on out. So what's in the report? Some of my fonts changed colors. What's in the report is the importance of studying geohazards in subduction zones. The first thing the report says is the obvious, which is that subduction zones are important. I don't think I need to tell this room that. They're important societally because the world's largest hazards converge there, literally. And they're also important scientifically because there's no natural laboratory quite like a subduction zone for having controlled conditions and systematic variation of variables. The subductology approach is powerful, and we can look along strike, or we can compare subduction zones, and we have a better controlled experiment than we often have in nature. So once that sort of general theme is articulated, the next thing the report goes on to do is to articulate the knowledge gaps and driving questions. And I'm not going to walk through this all right now because we're going to spend the rest of the morning on this. So I'm going to just let them sit here for a minute on the screen, but each of the working groups and integrative groups each articulated their own driving questions. They figured out their own knowledge gaps, and then using these driving questions and these knowledge gaps, work out strategies for answering them. What also emerges from the report is that there's a lot of overlap, that separating things out into faulting and earthquakes and magmatic drivers and landscapes and seascapes and building equity and modeling, it's kind of artificial because there is so much overlap between our scientificals and our practical needs. Scientifically, the overlaps fall into several different categories with 6 overlapping themes articulated. For instance, at the top of the list is forecasting and prediction. If you are looking at geohazards, you are intrinsically interested in to what extent the geohazard is predictable, and if so, how do you do that? Of course, not all geohazards are intrinsically predictable. We don't know that. Some are. I mean, some volcanic eruptions are predicted on a regular basis. That's a fact. Others are not. And what we don't know is whether the unpredicted eruptions are unpredicted because of a lack of observations in the right space, a lack of our understanding and data in the right space at the right time, or some physical difference in those eruptions. And so that's a question that one can answer, putting instruments in the right space at the right time in a regular and systematic way. I think we can all agree that the earthquake problem is trickier. We really don't know to what extent earthquakes are predictable, but there is enough information out there to suggest that at least some earthquakes, some of the time, might have foreshocks and perhaps slow slip before them. And so this is a question we need to address, is to what extent earthquakes are or are not predictable. So that's sort of, I don't know how to put it, the flavor and the spirit of what we do and how that interacts is that forecasting and prediction, and some specific tools as well. There are also some really more concrete ways that we overlap. The subduction zone system is a system, and there's a mass balance and there's an energy balance to the system as visualized on the bottom. And what goes into one geohazard comes out on the other side and inputs to the next one. And so knowing the boundary conditions of one is telling you the initial conditions of the other. And so it's really actually quite hard to physically disentangle the system. And that's also comment about rheology and stress. The same kinds of constitutive laws are required to, and the same stresses are driving all of the hazards. So we see quite a lot of overlap between what we're trying to accomplish, and there's also a lot of practical overlap. There's overlap in everybody needs geology. Everybody needs to know the history of the system. Everybody needs to know how the ground moves, geodesy. Everybody needs remote sensing. And these overlapping leads could be leveraged so that we could get a lot more science out of our data and our dollars. Okay, so those are the problems. How do you solve them? And this is where the RCN spent most of its effort, is how to solve them. And to try to address this problem of strategies to solve them, we borrowed a strategy from NASA, a traceability matrix strategy, where you set up a matrix where the rows are the questions and the columns are various strategies, observations, data, instrumentation, and you try to figure out what you try to trace the science through your various strategies for solving. And it's actually a very illuminating exercise in terms of making your thinking disciplined. For those of you who would like to see them, the traceability matrices are included as appendices to the reports. And they lead to notional experiments. Notional experiments means using that idea of tracing the science through to the observations. What would an experiment look like in kind of a cartoon sense, that very abstracted, that would actually address and solve the problems? And so that exercise led to a parsing of the problem into instrumentation that can address the problems and activities that can address the problems. Instrumentation, observational instrumentation, breaks down into three big arrays: mega array to address the faulting and earthquake problems, bulk array to address the volcano problems, and surf array to address the landscape seascape problems. And I'll tell you what's in those in a minute. And you will notice as I talk about those that certainly their logistical and instrumentation needs actually overlap quite a bit. And sometimes we refer to the whole package as multi-array. And that is complemented by activities. Activities in an SZ4D sense means the things that you do to make sense out of the data. The things, without activities, data is just bytes in the machine. And to make science and not bytes in the machine, you need to analyze the data. You need human beings to do the research. You need other observations, field geology, geophysical imaging to provide context. You need numerical modeling to make, you need lab experiments, and you need training and outreach. So drilling down a little bit, these observational arrays that provide the bytes in the machine are driven by the scientific questions and by particular observations. So the mega array schematically is driven by in large part by our geodetic understanding of subduction zones, that we know there are slow slip events. We know there are earthquakes. We know we have a complex, rich seismic cycle, both in space and time. And what we need to do is understand the relationship between the space and time components of the seismic cycle. And to do that, the mega array has a backbone that is an amphibious array of both seismic and geodetic instruments over a multi-100-kilometer swath comparable to the size of an actual segment of a subduction zone. And after the locking map is determined, the sort of part B of mega array is to drill down on the edges of lock zones with a long-term characterization of areas of interest to look at transient behaviors. The Volk array schematically has two parts, again, driven in large part by remote sensing observations. The idea here is that we know that when we look from space, we see volcanoes moving all the time. There are many more active than are instrumented. And so that really sort of begs the question of what we would see if we consistently, systematically instrumented 30 to 50 volcanoes. Instead of getting our instruments out there when the eruptions are already on the way, if we saw the whole cycle and we were sitting there ready to go with background and compare, this is what we really need to do comparative volcanology. So those are the volcano sensor arrays, and the volcano imaging arrays are a smaller set of volcano pairs that are more densely instrumented in a way to image the transcrustal magma system. Surf array also has its roots in remote sensing in some ways. And it is a surf array is a combination of topographic, bathymetric, and environmental sensing, specifically to set up a notional experiment that is a paired set of subduction zone segments where you can compare and contrast the resulting landscape and seascape knowing their environmental inputs. And so that's a combination of remotely sensed topography, ultra high resolution bathymetry, and on-land environmental sensing. Okay, so those are the arrays. And as I keep saying again and again, because it bears repeating, the arrays are not science. Sorry, did I really say that? The arrays are not science. The arrays are data collection that enable science. Science is the activities. And so they're useless without them. Activities, meaning field geology, geophysical imaging, experiments, and modeling, is what stitches the enterprise together and allows us to make generalizable analysis of the data. And that's particularly important for subduction zones, because what I'm going to say in half a sec here is what we really want to be doing is taking data in one subduction zone and learning things about a different subduction zone. And if you're going to do that, you need to understand how to generalize, and that requires the activities. Okay, so that's what needs to be done. I have said nothing up to this moment about where it is happening. Right, all these cartoon notional experiments, and where should it be done? So this is the other place that the RCN committee spent a ton of effort. We systematically made a list of every single subduction zone segment in the world. There were about 60 some of them. This is the map. And we really did walk through each and every one of them and say, what about here? What about here? What about here? And we asked the question whether scientifically those cartoon notional experiments could meaningfully be done and get the data required in that location, as well as whether logistically it made sense. And there are logistical hurdles that are just difficult to overcome in certain parts of the world. For instance, one requirement that we worked with is that according to the US State Department, there couldn't be a level 4 travel advisory for non-COVID reasons. We couldn't be sending NSF funded researchers in large quantities to a place that was that unstable. And so that got us down to a pretty small list. And you can read the report in detail. The geography chapter makes a good read about why certain areas got eliminated or selected. But basically what it boiled down to is the RCN is recommending complementary domestic and international sites. Domestic sites, because we are an NSF-funded entity, and we do have an obligation and responsibility to learn something meaningful that mitigates risk in the U.S. However, the subduction zone with the highest risk in the U.S., Cascadia, is actually not a particularly good place to be taking a lot of long-term observational data because it doesn't have a lot of events. And you're in this crazy situation at Cascadia where you could put out, say, mega array, and you could either record no major earthquakes or events, or even worse, in a way, be there for the major event, and that's it. In which case, you've learned nothing of use to society prior to the major event. So it seemed a much better strategy to do some work in the domestic subduction zones and complement it with sort of the domestic zones sped up, a more active version of Cascadia, which might be known as Chile. And that if we put the bulk of the instrumentation in Chile and work strategically with these activities to get that generalizable science and be able to port that understanding to the US, that was, to us, scientifically the most sound strategy to move forward. With some portfolio in Cascadia and Alaska as well. All right. So here I've been talking to you for a while now about reports and committees and burning a lot of scientists' time on this effort. What's the point? Why are we doing this? We would like to instigate a large-scale program. That's the point. But we'd like to answer the questions, and we'd like to assemble the resources to answer the questions. That's what, as scientists, we like to do. We like to answer things, not just ask them. And so it's worth taking a moment to think about how large-scale scientific efforts get going in the U.S. How do large-scale programs in the U.S. happen? There is a very long fuse on how large-scale programs happen. They start by organizing. Organizing is important. Having meetings like this is important. Having the Boise meetings important. And then once you get a little organized, you start writing reports. And reports are important. Reports articulate a community consensus around an issue. 3,400 people fed into it. Not all 3,400 people agree with it necessarily, but there's significant input. And then after you've got some reports written, you start applying for opportunities. You apply for existing opportunities and you work with the funding agencies to create new opportunities. And then those opportunities hopefully will, sometimes you'll put a proposal in that doesn't quite match, but at least we've got a proposal in and got the conversation starting, and hopefully we can collect both within agencies and across agencies. I will say quite clearly, I don't expect there ever to be an SZ4D proposal, a singular SZ4D proposal. That's not going to exist. The vision's too big for that. But what we need to do is start to strategically move forward, applying for opportunities. I'd say the enterprise right now is about here. We're kind of done with report writing. And we're starting to apply for opportunities. And so this is why, as Donna said in the beginning, this is the moment to re-engage if you haven't engaged or engaged before and sort of moved away, re-engage the community to start thinking about what goes actually into proposals. If you took a back seat for report writing, good on you. Now's the time we need your energy. Okay, so proposal writing. There's a conundrum on proposal writing for SZ4D, and I'm going to call it the collective impact conundrum. Collective impact is actually a bit of a technical term. It's something that comes out of the diversity DEI community and the social science that goes of science. The collective impact means that we have some sort of framework in which the sum of the parts is greater than the whole is greater than the sum of the parts, and that that we organize ourselves in a way that our collective impact actually solving the questions is possible because we've got all the pieces of the puzzle talking to each other in a strategic way. SZ4D believes strongly in collective impact. That's why we have such an extensive and elaborate report. Collective impact is problematic in our current funding ecosystem environment because the mechanisms to fund infrastructure are different than the mechanisms to fund science, which are different than the mechanisms to fund collaboration. Those are all three separate things that one could apply for at NSF. Mechanisms to fund infrastructure have names like major research, MRI, infrastructure, mid-scale, MSRI. Our MREFC is the big one, is major research equipment and facility construction, things greater than $100 million, but those are all infrastructure only. Mechanisms to fund science are things like the core programs that we all apply to, the geophysics program, the tectonics program, the GLD program. There are mechanisms to steer a little bit of collective impact in science called centers, the geohazard centers, science technology centers, and a dedicated science program, something like the GeoPrisms program would be another mechanism to fund science. Mechanisms to fund collaboration is actually the place that we've been most successful thus far as SZ4D. We had the RCN, and you'll notice I keep referring to the RCN in past tense, and that could be confusing. You know, what are you all doing here if the RCN is gone? The RCN came to a close with the publication of the report last week, and it is replaced by a standalone SZ4D entity. As of summer 2022, NSF has provided SZ4D with another $1.7 million to fund what is called the Catalyst proposal. Hey, everybody just perked up. That was kind of cool. Which is what is paying for this meeting and is what we're currently operating under. And I'll explain to you what's in that Catalyst proposal in half a sec, which is money to fund collaborations and to continue. And it's a strong vote of confidence, obviously. That's quite a strong vote of confidence from NSF that this collaboration and planning activity is worthwhile. And so there are going to be parts of this meeting where we're going to talk about one mechanism, either an infrastructure mechanism or a science mechanism or a collaboration mechanism. And we're going to have a conversation about one of these. And it doesn't mean that we're forgetting about the other ones. It just means that we're having a tractable conversation at that moment in time because we can only talk about one thing at a time. But it is certainly a puzzle that we all have to put together, is how to make all three of these mechanisms dance together. Okay, so as I said, we have been quite successful in getting fundings for collaboration. The Catalyst proposal, of which I am the PI of, is a plan to move SZ4D to the next level. Specifically, what the Catalyst proposal funds is a staffed center, pays Anna East and Dana, who you might have met out there, and staff is essential. There's only so much volunteer scientists can do. To organize the work, and the staff is specifically charged to organize the work consistent with the principles of BECG, building equity and capacity, and this is part of building our internal capacity, following a collective impact model. Number two, the Catalyst proposal funds technical project management. There is only so far scientists can go in drawing cartoon notional experiments. At some point, somebody technical needs to get involved. An engineer needs to get into the picture. Somebody who understands budgets need to get into the picture. And so that is funding for those sorts of people and activities to actually put some flesh on these bones. And specifically, we've been engaging with IRIS and UNAFCO, not just on the geophysical instrumentation front, but because they have the budgeting and project management experience on all fronts, to help us with these technical project management activities. And then the third piece of the Catalyst proposal is preparatory work for geological modeling and laboratory facilities for the activities, which includes a lot of workshops and some modern engineering design work to fully articulate what is necessary there. And so ultimately, we're trying to head towards a pretty complicated looking SZ4D structure as articulated in the report that includes a center staff, technical project management, collective impact, and importantly, I have a pointer. These 5 facilities in purple, which are offshore instrumentation, onshore instrumentation, human deployments, which is a very funny word, and we've got to change the name of this. I hear it. Melody will be talking about it later today, but human deployments means infrastructure support for field geology, where humans are the instrument collecting the data. And those need to be supported. Otherwise, we end up with weird imbalances in the science and what we end up knowing in the end. And modeling collaboratory, and lab and sample. And you'll be hearing about all of these later on this morning. That complicated structure has a complicated set of governance committees. There's no need for such complexity at this stage because we don't have the facilities yet. So what exactly are those committees going to govern? So right this second on the Catalyst proposal, we have what we're calling a transition structure, which is similar to the RCN structure, these working groups, FEC, MDE, LNS, MCS, BECG, plus a couple new committees. We are now, the new committees are parsing off functions that were frankly with the steering committee before and the job's gotten too big. One of them is the operations planning committee, which is charged with overseeing that technical project management job of actually designing the facilities. And the other is the collective impact planning committee, which is charged with overseeing the science job of stitching this, making sure no piece of the science falls on the floor, as well as no piece of the community falls on the floor. These committees are color-coded by high commitment orange. That means get ready for every other week Zoom meetings. And logo or commitment, maybe you don't want to spend quite that amount of time on Zoom, but still want to get engaged. And those would be what the, in their current incarnation, the working groups and integrative groups are. These committee structure was announced in May 2022. Very quickly, in the course of a few weeks, we got more than 200 volunteers for these committees, which again, I thought was an amazing vote of confidence. Not everybody got selected for a committee this time around. That was kind of on purpose because we're going to do this again next year. Our goal is to have 3-year staggered terms. So every year, some people rotate off and some people rotate on. So if you didn't get on a committee that launched fall of 2022, don't worry about it. Volunteer again next year. We didn't want to use everybody in the first round. And when I say we, I actually don't mean we at all. I mean the Committee on Committees. There was a standalone independent entity called the Committee on Committees. You could look at the members on the website, and it was their job to take that list of volunteers and parse them up among the committees and make sure that the committees were balanced. It disciplinarily, demographically, in all the ways that you would want a committee to be balanced, and saving some ammunition for next year as well. And so those new committees launched in the fall of 2022. Over the last month or so, most of the committees launched. And here is the new steering committee, which about a third of the old steering committee rotated off. And that is our intention here on out. We'll have about a third rotation every year for these 3-year staggered terms. And please keep your eyes out for a call in the spring. In addition to the Catalyst proposal, which is funded, we have put in October of this year, a month ago, another proposal to fund international collaboration. The Catalyst proposal funds domestic collaboration. The proposal pending, it went into a, call it NSF, called ExcelNet, which is for funding international networks of networks. And it's called the SZ4D proposal. And this is has 11 partner networks from around the world that have geographic spans as well as disciplinary spans across the geohazards. And it is to coordinate on our common interests, specifically to compare observations of subduction zones, both through workshops and comparing and swapping understanding, scientific understanding, as well as swapping data. And providing some infrastructure to manage and disseminate data. It is also mission 2 of SZ4D is to cooperate for consistently instrumenting critical subduction zones with an emphasis on Chile. There is a subset of SZ4D that is SC ChileNet, given the SZ4D priorities. And then there is mission 3, which is to develop and nurture an international diverse early career cadre of early career scientists. And there's a special emphasis there on the fact that we are, this generation of early career scientists has been impacted by the COVID era and has really lost out on a lot of networking opportunities, and to try to support them through their next career transitions. Okay, so I'm getting close to wrapping up here. Sorry, I'm sure I've gone over time. Have I gone over it? Not yet. Well, I'll just keep talking then. The road ahead, this is a long road. This is not, nobody should be expecting SZ4, mega array to be launched tomorrow. That would be pretty unrealistic. We're getting a lot out of it scientifically simply by talking to each other. So I don't think in any sense this is time wasted. I'm learning a lot every time I speak to any of you. We're sort of at the beginning of phase 1, which is developing the facilities. It's worth pointing out that the SZ4D documents do articulate a phase 0, which was writing the reports and figuring out what it is we want to do, and we're done with that. So it's not even on the chart anymore, but phase 0 is done. The implementation report is out, but phase 1 we expect to last 1 to 3 years, depending on what part of phase 1 you're talking about. I certainly wouldn't expect a raise in the ground before 3 years from now. I think that would be totally unrealistic. Then once and it might be 5 years, it might well be 5 years. Phase 2 is all geohazards We're looking at rare events. We need long-term observation, more than a decade of data and complementary activities. That's phase 2. And phase 3 is synthesis. Let's not forget synthesis. Without synthesis, it's not science. So with that road ahead in our mind's eye, let's come back to what Donna put up here on goals for the meeting. The goals for this meeting, this community meeting, are to share subduction zone science. Let's not just be report writing. Let's actually talk science to each other, because that's what drives the whole thing. And networking with other subduction zone scientists. That's where collective impact comes from. To inform the community about SZ4D efforts so far, there's been a ton of activity, much of it happening in the Zoom era. And so it's important. Zoom does have a tendency to silo. It is an unfortunate reality. And so let's break that silo. And to get some community feedback at this critical juncture as we move from phase 0 to phase 1 of what it is we should be doing moving forward. And to those ends, we have the program committee has developed the agenda for these 3 days. The first day today is primarily informational. It really is aligned with just trying to get everybody on the same page about what's happened so far or where our starting point is. Because the last thing we'd like to do is unravel this giant effort of the implementation report and start over from ground zero. We want to use that as a building block to move to the next stage. So there's a lot of information that simply needs to get out there. And then we want some feedback on where we are. And so that's the breakout. One today will be a breakout session where we break up into different groups online and in person to discuss SZ4D priorities for observations, modeling, and experiments. And nobody wants to participate in a breakout group that has a lovely discussion that doesn't go anywhere and then just sort of dies at the end of the session. That's kind of a waste of everybody's time. So each of these breakout groups has been strategically set up to feed into a particular part of the committee structure. So breakout 1 goes to the working groups. And so instead of, often you may have seen at meetings that breakout groups, you have a breakout group and then somebody comes back and reports back and tells you what happens, the whole group, what happens in that. And then you do it again and you do it like 8 times in a row and everybody's like eyeballs are rolling back in their heads at that point. We're not going to do it that way. What we're going to do is in your breakout groups, you have documents, you have scribes. The docs are really important, these Google Docs. You're going to scribe into those Google Docs. And then there are representatives of the working groups who are charged with synthesizing overnight the breakout group documents and reporting back as a group, you know, once of what happened in the breakouts. And they will report back to the room the first thing in day 2 morning. And that'll be your chance to say, hey, you didn't get it right. That wasn't what happened in the room, or that was, and you can make sure that your breakout discussion got a good landing point within the SZ4D committee structure. Day 2 is will be on cross-cutting and translational science, emerging methods and technology. And that breakout will be on cross-cutting and translational science, which will appropriately land with the collective impact committee, which will again serve the same function of synthesizing those breakout documents for you, coming back, reporting back to the room. You could correct them and make sure that your conversations land appropriately. And then the final one, breakout 3, collaboration and funding strategies, they won't have overnight to synthesize, but will land with the operations planning committee in the same way. So that's all I have to say, right as Mark gets up to tell me that I'm done. But I am in fact done. Thank you